And laws of logical reasoning. So we have four laws here. The first one is commutative, second one is associative, the third one is distributive, while the last one is De Morgan's law. So what I will do, I will use the normal basic operation to explain that. They said A or B is the same thing as B or A. Why A and B is the same as what is equal to B and A. So see what I'm saying. This first one is like if you are given 1 plus 2, I'm using basic operation plus, is the same thing as 2 plus 1. Or maybe if you have 1 times 2, is the same as 2 times 1. So in mathematics, that's the meaning of commutative law. So it doesn't matter which one you start with, it will give you the same result. So coming to the second one, associative law, if you notice the symbol here, disjunction, it must be the same. So we have more than three statements. So if you notice, they will have the same thing. So see what I'm trying to say. If someone say should do 1 plus 2 plus 3, so you can decide to add 2 plus 3 first before doing 1 plus 2, 1 plus the result, that is 2 plus 3, or you can add 1 plus 2 after, add 3. So that's the meaning of the associative law. If you check, you say A or B or C is the same as what? A or B or C. Do you see? So it's the same thing. That's the second one. Coming to third one is distributive law. If you look at this, you have more than 3 statements, and we have or and yes, but you have 2 different symbols. So see what I'm trying to say. Assuming someone asks you to do 4 times 2 plus 3, you can do it 4 times 2 after you do what? 4 times 3. So that's the meaning of distributive law. Why the first one is that's before this one is associative. So learn that. Now associative, the sign is the same, it's constant. But in distributive, you change the operation. The operation must be the same if it's associative, but distributive, you must change. So that's what this law is saying. So De Morgan's, what we have here, if you have negative, if you negate A or negate B, it's the same thing as you bring out the negate, you see, and now change the operation, which is and. Do you see it? So that's same thing here. So what I will do now, I will use the law, the truth table, to prove some of the law. So I'll prove the De Morgan, one of the De Morgan's law. So that's it. That's De Morgan's. Want to prove it. So let's start. We start with true, that's true, false, true before we have false. So we have negate A, so which is false now. If it's true, opposite. Why B? Negate B. That's it. So this is false, true. This is true, false, and this is true. Because they are false. So we are done with this one. So we have negate A, that's negative of A or negative of B. So C negative of A, C negative of B. But remember, for this to be false, both of them must be false. So this is off. For this to be false, both of them must be false, and as you can see, both of them are false. We write false. Remember, I'm using the general, the summary up here. That's what I'm using. I told you it's false when both are false. So that's it. That's saying this is false when both are false. So look, let's just check where both of them are false. makes easier. So none again, we have true, true and true. So you don't need to waste time. You don't need to waste time. Just check where the general formula lies. Put it others. The next one we have A and B. A and B, and I told you for A and B to be true, both of them must be true. So let's look at A and B. Where is true? Both of them, that's it. So we have true, and we have true. Is there any other place? It's true. So others will be. So coming to this one, we have A and B, the negative. So we've gotten this. So negative is false, negative is true, negative is true, negative is true. So that's it. Let's check whether we are correct. We want to check that this, so whatever you get to the left must be the same as the right. As you can see, what is here is the same as here. Whatever that is here is the same thing as here. So whatever that is here is here. So whatever that is here is here. So we'll prove that. We'll prove the one of the De Morgan's law. Let's finish up. So this one, we want to prove one of the distributive law. So that's it. I decided to fill in this before so that it will be faster. So we have B and C, and I told you for it to be true, both of them must be true. So where is B and C? C, B and C. So both must be true for it to be true, otherwise false. So true. Is there any other true? True. Is there any other true? So others will be false. So it's simple. Once you use that general formula, you know others are now the opposite. So I have A or B. A or B. A or B is false when both are false. So let's look where both are false. A and B. So false. So which one again? Okay, down here we have false. So others will be true. So that's how you do it. Use the general condition. You now do others. So why C? A or C? A or C is false when both are false. So let's look at AC to know where both are false. So we have here it's false when both are false. Yes. So any other place that A is false and C is false. Okay, down here is false. Yes. So meaning that others must be true. So that's how you fill the table. You don't need to waste time. Use the general formula, fill it. You now the opposite. The remaining is now the opposite. So why this one we have A, we now have or B and C. So first we've gotten B and C. So A or this, A or that. And remember I told you or is false when both are false. So let's look out where both are false. Let's look out where both are false. Okay, we have false here. Okay, do you have any other points where both of them are false? This is false, this is false, so this is false. So any other place, false, false, false.
Okay, false. So this is also false. So since we've gotten that, others will be true. So we have true, true, true. So the best thing is just use general formula. Put that one. You can easily put the opposite. So coming to this one, we have A or B, intersection A or C. So let's remember, for them to be true, both of them must be true. So let's look for true. This true. This is also true. So this is true. This is true. This is also true. So the two must be true. This is true. This is true. This is false true. So it's false. So any other place that true. This is true. So others will be false. So as you can see, the second, because we asked to prove this, you see that the second to the last column is the same as the last column. So we've proved that. Thank you.